Okay, we've talked a little bit about the periodic table, but I want to show you how we can use the periodic table to understand the structure of elements and how they bond. Remember, we talked about groups, and the groups here, the columns are our groups, and groups, remember, are the number, will show us the number of valence electrons. We are going to only use these that are unblocked out. You'll see here that I have changed a bit on the periodic table from the last video, and I have X'd out everything that we are not going to worry about. So you'll see that here we have column 1, 2, 3, 4, 5, 6, 7, and 8. Our groups, again, tell us the number of valence electrons, and then we have our rows. And our rows, remember, are the number of orbitals. And orbitals are where our atoms the electrons in the atoms will live, if you will. All of our atoms, remember, have a nucleus. So we will always start out with a nucleus. And inside that nucleus, we have our protons and our neutrons. For the periodic table, these are representing elements that are uncharged, meaning that our protons and our electrons are equal. So if I have 6 protons, I have 6 electrons. Now, for neutrons, that is not always the case. Our protons and our neutrons may not always equal, and those will cause some changes in the atomic mass. However, for this class, unless I tell you otherwise, our protons and our neutrons are always going to equal. So, the rows tell us the number of orbitals, the groups tell us the number of valence electrons. Now, let's talk about those orbitals. Those orbitals are going to represent each row that we have, and each orbital can hold a specific number of electrons. Now, we are going to look at what we call the octet rule when it comes to the electrons in the outer orbital. The octet rule is basically a chemistry rule of thumb that says that all valence shells want to have 8 electrons so they can mimic their nearest group 8 neighbor. So they want to be like this group 8 column. Because these are completely what we call inert. They don't bind with anything. They don't form bonds. So here in the other parts of the periodic table, we're going to see how these elements can go about filling up those orbitals. So if we have row 1 can hold 2 electrons. And you'll see here in row 1, I have 2 elements, hydrogen and helium. Row 2 can hold 8 electrons. Row 3 can hold 8 electrons. And again, many of you will remember from your high school chemistry or even chemistry out of high school that row 3 can actually hold 18 electrons. But again, we're not talking about energy shells or anything like that. We are talking about the octet rule. In row 4, we're only going up to calcium, and so we're not going to worry. But again, it can hold 8 electrons. Okay? So if I am looking at an element here on the periodic table, let's go over here to carbon. Carbon is an easy one to look at. So in our carbon, if you have a periodic table that you can see up close, or using this one here, carbon has 6 protons. So I have 6 protons, and for this class I have 6 electrons. But this means I also have 6 neutrons. But I also have 6 electrons that have to fit in my orbitals. Now, how do those fit? I'm going to look and see what row is carbon in. And I can see that carbon is in row 2, so that means I have 2 orbitals. Pardon me. So I've got my first orbital and I've got my second orbital. If I have a second orbital, that means that my first orbital is full, okay? So my first orbital, you'll see, can hold 2 electrons. Let's change color here so we can kind of keep these things straight. So my 2 electrons can fit here in my first orbital. And if I come and I look and see what column carbon is in, I can see that carbon is in column 4. So I have 1, 2, 3, 4 electrons in my outer valence shell. What this tells me is that if my carbon is wanting to fill its outer orbital, it can form 6 bonds by pairing electrons with some other atom. Remember, electrons like to be paired, and so in order to fill this orbital, carbon has to find 4 more electrons. We'll see how that happens when I discuss on another video on bonding. So you'll see here that I have row 2, so I've got my 2 orbitals. I'm in column 4. I have my 4 valence electrons, and since my first orbital is full and my valence orbital is following the valence number of electrons, you'll see that I have 6 electrons in my carbon atom, which matches my 6 protons in my nucleus of my carbon atom. Let's do one more. Let's move over to elements, and let's look here at oxygen. Oxygen is also in row 2, so let's start with our little nucleus here, and it's in row 2, column 6. So I've got my row 2, so I've got my 2 orbitals, and my column 6 tells me the number of valence electrons. So row 2, I can have 2 electrons there. I know I've got 2 electrons there because I have a second orbital. So the first one, again, must be full. The outer orbital, this valence orbital, I need to follow what it says here on the periodic table. It says that it has 6. Now, this is where we need to understand how electrons like to bond. Electrons want to be paired, but they must pair in a specific manner. So if you will put your electrons in the outer valence shell, 1, 2, 3, 4, and then start pairing them again, you will see that I have 2 unpaired electrons here. This will allow oxygen to form bonds with other atoms. If I were to pair everything and do 2, 4, and 6, that means I would have no electrons that were available to bond. And we know